Hello, thanks for joining this physical science video. We're going to be talking about the end of the light lesson, which is 5.5 light measurement. So there is a review video that goes over this. We're just going to mostly focus on some practice problems today. So it's important to realize so that we know where we're getting these formulas. Light spreads out as it moves away from a source. So if our source is here, this X here, and we're shining light, it starts out in one small spot and then it spreads out. And as it does that, it covers more area, but it covers that area less intensely. So if you had a sheet of paper here, it's going to light it up really brightly, but just a small piece. If you go farther away, you go twice the distance, it's actually going to cover 4 times as much area, but it's dimmer. Okay, it's not going to light it up as brightly. And if you go 3 times the distance, it's actually going to cover 9 times as much area, but it's even dimmer. So what we're talking about is measuring the way that light changes with distance for some of these formulas. And we've got some terms that we've got to use. So luminous intensity is the intensity of the source of light. Okay, so we're not talking about the light, and I'll go back, we're not talking about the light as it hits these papers, we're talking about the intensity of the source, so back here. So that is intensity. And the unit that we use for that is called candelas. And the rate at which the light energy is radiated out from that source is called luminous flux. And then the rate at which it's received at a surface is called illuminance. And that's looking at the light, being received on these papers. How bright are these papers being lit up? That's the illuminance. Okay, so we just need to keep those 3 terms straight. Luminous intensity is the light shining off of the source, and it's kind of similar to luminous flux. That's the amount at which it's radiated away, and then the illuminance is what's being received on the surface. So by moving a surface closer or farther from the same light source, you're going to change how much illuminance it has. So we've got some formulas for that. Illuminance is calculated with the formula E equals I over S squared. So let's see what these all stand for. E stands for the illuminance. It stands for illuminance of the surface. So that's what we're solving for in most cases. I stands for the intensity of the light bulb, and then S stands for distance. So we're not actually using that middle term in this one, the luminous flux. We're just talking about intensity, distance, and then illuminance on the surface. So I, the intensity, is what we're starting with at the light bulb, and then distance is going to affect how much the surface is lit up, so the illuminance of the surface, which is E. And then you can rearrange this formula. So this is the same formula rearranged. If we want to find distance, we take the illuminance, we take the intensity divided by the illuminance, and we take the square root of whatever we get, and that tells us how far away the light is. Or you could also flip it around and find the intensity of the source. If you know the illuminance at the surface and you know the distance, you could use that to find intensity at the source. So here's some practice problems. I just wrote our words up here so we remember what stands for what. So E is illuminance, I is intensity, S is distance. And our question, what's the illuminance on a surface located at a distance of 6 meters from a 180 candela lamp? So we're looking for illuminance, that's E. We know the distance is 6 and our intensity is 180. So this shouldn't be too bad. We have our formula and we just put the numbers into it. So intensity is 180, distance is 6. We remember it's distance squared, so we have 6 squared. So now we just have to solve for that. So remember, with order of operations, we do exponents first. So 180 divided by 6 squared becomes 180 divided by 36, okay, because 6 squared gives you 36. And then just divide. 180 divided by 36 gives us 5. So that's our final answer for this problem is 5. Next problem, we have our same words up here. E is illuminance, I is intensity, S is distance. Our question is what the light intensity of a source is 80. So that's going to be intensity. That's I. And the illuminance is 5, so that's going to be E. That's our illuminance. And we're looking for distance. We're looking for how far is the surface. So because we're trying to find distance, we need to use the version of the formula that starts with S equals for distance equals. And then we plug our numbers in. Distance equals intensity divided by illuminance, and then you find the square root of that. So we have intensity is 80 divided by 5, and then we do the square root of that. Now, order of operations here, you can kind of look at the square root as if it's a big parentheses. So like that. So we do whatever's in the parentheses first, which is 80 divided by 5. 80 divided by 5 is 16. And now we still have that square root there. It didn't go away. We just did our division first. So now we have the square root of 16. And that gives us 4. So the distance is 4 meters. So we know the intensity of the light. We know what it's like on the surface that it hits. So we could use that to figure out the surface is 4 meters away. And the last thing they talk about is a photometer. And this is a piece of lab equipment, and what it's used to do is to compare the intensity of light sources. So what you do is you start with a light source that you know and a light source that you don't know. And this is actually going to be the one that we don't know, light source number 1, and light source number 2 is the one that we do know. That was supposed to be a check mark. Let's try that again. There, that's the one we do know. So what you do is you put these 2 light sources up, and they're shining at the photometer that's over here, and that's measuring the 2 of them. And what the photometer is going to do is help us compare the 2. We want them to be equal. So if we move this light source forward or backward, we're changing the intensity that arrives at the photometer. So that's what we just talked about. As you change the distance, you get a different illuminance on the surface. So we're getting a different amount of illuminance on that photometer. So we know the intensity of this one, and we're moving it backward and forward until the illuminance that reaches the photometer is the same as the illuminance that reaches the photometer from over here. And what they'll do then is they'll say, okay, we know the intensity, and we figured out the distance, and that'll help us find the illuminance over here. And then we could work backwards and say on this side, all right, to find the light source, we know the illuminance, and we could figure out the intensity. So this is the formula that we end up getting for it. It looks a little different than our last one. It actually, I know, looks terrifying, but it's not as scary as it looks. L1 is the intensity of the unknown lamp, and L2 is the one that we know. Okay, so those are pretty, L1 and L2. That's all we have, the 2 intensities. And then over here, S1 is the distance from the photometer to the unknown lamp. So this is a distance, and we square it. And S2 is the distance from the photometer to the known lamp. So that's another distance, and we square it. So we just have distance squared divided by the other distance squared times the intensity of the lamp that we know. That's all we do. Okay, 3 things. Distance squared divided by the other distance squared times the intensity, and that gives us the one that we don't know. So here is a practice problem to use it, and you can ignore these page numbers. Suppose you look for the photometer's eyepiece, and the fluorescent discs appear to be equal intensity. Okay, so that's what we want. It's set up correctly. If the distance between the photometer to lamp 1 is 500, and the distance to lamp 2 is 300, and the intensity of lamp 2 is 17, what's the intensity of lamp 1? So those are the 3 numbers that we put in for these letters. We have our distance, our other distance, and our intensity will be 17. Okay, so it looks like this. Our distance for lamp 1 is 500 millimeters. Our distance for lamp 2 is 300, and our intensity is 17. That's all you have to do is put those numbers in. Now it looks a little bit less scary. We still have the squares there. So remember, with order of operations, exponents comes first. So 500 squared is 250,000, 300 squared is 90,000, and now we divide those and then multiply by 17. 250,000 divided by 9,000 times 17 gives us 47.2. So I know this formula looks kind of terrifying, but you just have three numbers that you have to put in the right place and then solve for it. Oops. Okay, so that actually does bring us to the end of this section. The next video will be about electricity. If you have any questions, don't hesitate to contact your instructor.